All right, hello everyone. So today we have a quadratic inequality that we're solving. So we're solving minus 3x squared minus x plus 2 less than 0. Right, so my first step would be this. I'm going to divide both sides of the inequality sign by -1. And if we do that, you would get 3x squared plus x minus 2 and then greater than 0. So whenever you multiply or divide an inequality by a negative, the inequality sign changes. Okay? So if it's a less than, it's a greater than. Now, you don't have to do that, but I just find it easier if the leading coefficient, which was in this case the -3, was just positive instead of negative. So that's why I did that. Okay, the leading coefficient just means the number that's in front of the square here, the highest power. Just makes things easier because really of the next step. So next step is going to be this. I'm going to factor this expression, this quadratic, this trinomial, on the left-hand side. And if you factor it, it'll be 3x times x, and then it's going to be a -2 here and a +1, okay? And I'll explain that, why I'm doing that right now. So at the end of the day, you're looking for numbers that you plug into that inequality, 3x squared plus x minus 2, and seeing if they're greater than 0 or not, okay? The easiest way to do that is by trying to write it out as a couple of factors and plugging in things in each of those factors to see if they're positive or negative. So that's why I did what I did right here. Now, here's the next step. I'm going to set each of these factors equal to 0. If we do that, we get x equals 2/3, and then you get -1. Those are the two places where 3x squared plus x minus 2 would equal 0. Everywhere else, that expression, again, 3x squared plus x minus 2 is either going to be positive or negative. 2/3 and -1 are only places where it's equal to 0. So how is that going to help me? So what I'm going to do here is this. I'm going to make a number line. Okay? And on this number line, I circled -1 and 2/3. 1 to bring attention to those numbers, and 2 because we're actually not allowed to include them in our solution here, because at 2/3 and at -1, your expression 3x squared plus x minus 2, so let me point to that in red because I keep talking about it, is equal to 0, not greater than 0. So those are not solutions. And the purpose here is that your solutions are going to be in one of these intervals, because again, that expression is going to be either positive or negative in one of those intervals. Okay. Well, how do I do that? There's a few ways of doing this. I'm going to show you one way. A few other ways that are a little more like computational, I would say, in terms of like plugging numbers in and such. But I kind of do this in my own, well, not my own way. A lot of other teachers do this and tutors. And here's how this works. I'm going to go ahead and consider each of the quote unquote regions that you have here. Well, they're intervals. All the stuff over here that's less than -1, and that's what this would represent right here. All the stuff between -1 and 2/3 are represented by that inequality, and everything greater than 2/3 represented by that. And yeah, so I wrote those boxes with those inequalities representing each of those intervals, and I wrote right here the factors on this side, 3x minus 2 x plus 1, and 3x minus 2 times x plus 1. And what I'm going to do is this. I'm going to find what the sign of each of these expressions, the 3x minus 2, the x plus 1 is, and finally the 3x minus 2 times x plus 1 is in each of these intervals, okay? So let me start with that first interval, x is less than -1. So I'm going to go from left to right. So if you have something that's less than -1, if you plug that into 3x minus 2, that's going to give you a negative. Okay, so I'm going to put a negative in for that. So just imagine plugging in something like -2. 3 times -2 is going to give you a negative. There's a more I don't want to say strict, sorry, a more rigorous way of showing that it's negative, but I'm not really going to go into that too much. Yeah, there's a way to build up that this in fact will be negative rigorously, but here we're just kind of interested in just seeing what's going on. So for all x less than -1, 3x minus 2 would be negative. X plus 1 would also be negative, so just imagine plugging in -2 plus 1, that's going to be negative. And therefore, the product of 3x minus 2 and x plus 1, that's positive. So then I'm going to move on now to the next interval, and I'm going to do the same thing. So from -1, for all numbers greater than -1, less than 2/3, just imagine 0. If you put 0 into 3x minus 2, it's going to give you something negative. And if you plug in something into x plus 1, it's going to give you something positive. And then 3x minus 2 times x plus 1 is going to give you something negative. And last but not least, from anything greater than 2/3, so just imagine like 1 here, we plugged 1 into 3x minus 2, that would be positive. 1 into x plus 1, that would be positive. And therefore, the product of two positive things is going to be positive. Okay. And our answer would be, because at the end of the day, I am working with the inequality in red. I am going to be, sorry, what I mean by the inequality right here is this. I'm interested in all the values of x for which this is greater than 0 into that expression. And that would come out to be all the stuff that's less than -1, or all the stuff that's greater than 2/3. Okay. And I'm going to write this in terms of a interval. This would be -infinity to -1, and with open brackets on both, on the number because we're not including on the answer, and on the negative infinity because we never put a bracket on infinity. It's always a parentheses. Remember, infinity is not a number, it's like a concept. That'd be your solution right there. Sometimes you're asked to draw these out on a number line, and if it were that the case, I'm gonna just redraw what I had earlier, my number line up there. So here's -1, here's 2/3, and it's essentially, it's all of this stuff and all of that stuff right there. That would be a solution. Okay. All right, so just to recap real quick, we went ahead and took our inequality, and I saw that the leading coefficient was a -3, so I divided everything by a -1, and I went ahead and decided to work with that inequality instead, making it greater than 0. And what we did was we tried to factor, and we always try to, if we can, factor these. In this case, it's a second degree polynomial, but if it's a third degree, fourth degree, we do the same thing. We try to factor. So if you haven't covered that in your class, don't worry about it, but in general, that's what we try to do. We try to factor. And we factored as such, and what we did was we set each of the factors equal to 0, because everything else other than the two numbers of 2/3 and -1, your expression 3x squared plus x minus 2 is going to be positive or negative. We made that number line just as a guide, and then we wrote out our intervals as such, like I did. And we went ahead and plugged our values in, and we got signs for them. I don't care about the actual value, I care about the sign that the value gives me. So you got negatives and positives all over, and yeah, at the end of the day, I was looking for things that were positive. So it'd be this, and then it'd be that right there, okay? Now, if you can't factor, so let's say you had x squared minus 7x plus 13, just for sake of argument here, the greater than 0, something along those lines. What you would do is you would go ahead and set this equal to 0 and use maybe the quadratic formula to solve. And just for sake of argument here, let's say you got numbers a and b here. And yeah, you would put numbers a and b on your interval. And if you couldn't factor, then that whole step where I made the the columns and the values and the intervals, that's hard to do. So what you would do is you would pick numbers in each of the intervals that you created, and you would put them back into that original inequality that you had, okay? Because again, we can't really factor this too easily. So therefore, we can't use that same method of products of factors. So you gotta plug numbers in, and that's how that would work, okay? Usually it's not the case, but just to let you know that can happen sometimes. All right, well, thank you so much for your time. Appreciate it. Hope this helps.